Now we have quite a bit of new stuff going on here, so let's talk through it in a little more detail. First, we've defined this new fetch user by email method that's responsible for looking up a user in our database by their email. In that method, we've actually defined our first SQL query with Postgres, which is exciting. We have this method right here. And again, notice this interesting $ number syntax we have in our query. The $ followed by a number is what's known as a query parameter and is best practice when inserting variables into queries. You might be wondering, why not just do the string interpolation or concatenate variables onto the string? And I would recommend, again, avoid this at all costs. This can, and often does, lead to what's known as SQL injection vulnerabilities, where someone executes arbitrary SQL on your server by sending malicious input to your application. Now, the package we're using, Node Postgres, supports what's known as parameterized queries, where passing text unaltered will allow it to be substituted safely on the Postgres server with battle-tested parameter substitution code that's implemented by Node Postgres themselves. So again, this is coming directly from the Node Postgres docs. This is the way you're supposed to insert variables into your SQL queries. Now, when we actually execute that query with db.query right here, for instance, notice that query is the first parameter, which is this string of SQL here, and the second argument is an array of all the parameters we want substituted into our query. Here we have only one, so the only item in the array is inserted where the number 1 is. So the very first item here, email.lowercase, is inserted right there. Now, if that query goes well and it returns something, we grab the user from the result rows, we grab the first row, and then we return the first row as the user to whatever calls this method. Now, the method that's going to do it, that's calling it at the moment, is our register method. So again, first, all we do is we check that the necessary attributes exist on the request body using the credentials.object.hasOwnProperty method. And again, this is just a standard object, JavaScript object specific method that just checks whether or not the property exists on the object, not whether or not the value is truthy. And that's good because if RSVP status is false, then if we just said credentials.RSVP status, that would evaluate to false, and we actually don't want that. We just want to know that it does exist. And so if it doesn't, we throw a new bad request error. Then, below, we use that newly minted fetch user by email to make sure that, hey, does that user already exist in the database? If they do, throw an error, say, not good. Next, we skip hashing the password for now, as it'll be a nice showcase for our next lesson, though we do lowercase that email, and then we execute another query, which is inserting the lowercase email, the password, the RSVP status, and the number of guests into the database before returning the user. So I think now is a good time to give it a run with an HTTP client. I'm using Insomnia at the moment, but feel free to use whatever client you are familiar with. I'm going to create a new one here called Wedding Registration, and it's going to be a post request with a JSON body, and I'm going to create it, and it's going to go to HTTP localhost 3001/auth/register. Cool, so let's send a post request with nothing in the request body to make sure that works. Let's send it, and we say, cool, we see this nice little error message, missing email in the request.body. And we also see that the 400 error has been logged to our terminal. Now, this is coming from this section here, where we are missing some of the parameters, and so it lets us know, hey, you didn't send an email. Okay, cool. Let's include the email. Let's say email is me@you.io, or something silly like that. Cool, missing password. So it is doing what we expect it to. Awesome, another informative error message. Now let's add the rest of the info, but let's use an invalid email this time. Let's send like password. Let's go with super secret password. And then RSVP status is true. And num guests is, let's go with 2. And let's send that, but let's make sure the email is incorrect here. Ah, interesting. Okay. We probably should validate the email directly to prevent sending this message to the client, as we don't really want to send some internal errors, especially with a 500 status like that. Now, there's a couple ways to handle errors like this, but let's just stick with the most very simple one, which is just to check if the @ symbol exists in credentials.email. So we'll just say if credentials.email.index of the @ symbol is equal to -1, which means it does not exist. Oh, let's throw new bad request error invalid email. Though I guess our actual Postgres check is making sure that it's at a position greater than 0. So let's do that. Let's just say greater than 0. Though it's considered 1 in the actual check, it's 0 for us since JavaScript is 0 indexed. And we can run that. Cool, everything seems to be working. Let's execute that again. Okay, still didn't work. If credentials.email.index of is not greater than 0. That's what I meant. Excuse me. Is less than or equal to 0 is what we wanted here. That's some incorrect logic. Might be. Let's try that again. Cool. Invalid email. Let's make sure if we send it at the beginning it doesn't work. Cool. Invalid email. Now if we actually correctly send this, and we just say me@u.io, and this is a solid, should be valid credentials. Hopefully, we get something correct. Let's see. Ah, amazing. Cool. Look at that. So we have now sent a valid request, and we got back the user, which means it was saved to our database. The created @ key was set, num guest, RSVP status. The user was given an ID, and it just works exactly like we wanted to, which is really exciting. Now let's go ahead and inspect our database just to make sure things are right. Let's go into pSQL and connect to wedding registration here, and then select all from users. Ah, incredible. And so look at that. Everything worked, but there's a troubling sign here. Look at that plain text password saved directly in our database. This is not what we want. We need a much more secure method for storing users' passwords. And the reason for that is a little complex, but we're going to get into that in the next video. For now, I think we're good. Let's go ahead and do our git dance with git status, git add, and git commit. Working registration system.